Hey, here we are one more time for another episode of Fun with Primes. We're going to do some work with Python, have some fun, and try to figure out primes. Now, you might ask, why primes? Prime numbers are very useful. Let's just leave it at that. If you can quickly make primes, it's very useful. So, once again, I am not going to waste time or spend time during these videos to recreate work that's already been done. That's counterproductive. It's always best to find work that's been done and leverage it. So that's what I'm doing here. So, in our previous episode, we took a look at prime numbers and we were stringing some primes together. In this case, 1313. Actually, those prime digits can be interesting, so let's dig into that a little bit more. So we're going to make a copy of this file and proceed. Let's call this primes 3. So the first thing we're going to do is we're going to generate all single-digit primes, and we already have some code that can do some of that. Primes up to blah. All right. Let's do a little list comprehension. Let's just see what we got. Give this a whirl in the shell. Primes up to 10. What do we get? It's a generator. That looks about right. Yep. And then we are going to choose where digits are equal to 1. And so why don't I just copy and paste the numbers from my shell? Because I might want to change a parameter going forward. I don't want to have to copy all the numbers in, and doing it by hand is error prone. I don't like producing code or data that could be subject to change or that might have errors. And this is far less error prone. So I'm going to go with it. So now we have prime digits. And now we're going to start producing stuff. Just to take off on what we were doing before. So we're going to make a number out of a series of prime digits. Let's go with up to 10 digits. And we need to do a little random thing here. Let us seed it. Let's see what we get here. Ah, there we go. Time. And we'll make it an int. Random dot choice from prime digits. And we'll get 10 of them. Let's just see what we get up to this point. Oh. Oh, yeah, that's right. All right, take a look at n. N is a number. And it is long, which is fine. All right, so now we have a number, and we're going to do factorization like we did before. So let's just step over. So now we have factors, and they all look prime. So then we're going to print it out, do our little test, and if it's ever not prime, break, which will break us out of the for loop. And then to break it out of the while, so let's see, how many do we want to do? Let's do 1,000. Okay, let's just see what we get with this. Oh, too many items in num. Interesting. Yeah, because someone used range. It should have been X range. Of course, we all know what happens when you use range versus X range. That's why that stopped. Let's try it again. Now it's going to run for a long time. Because is prime can be very laborious the way it's written here. All right, so let's cut that back a little bit because we're going to have to optimize this prime. So let's go with 5 digits. There we go. And every single number that we created by using a string of prime digits is perfectly prime. And a perfect prime in this context would be a prime number that factors into prime numbers. Of course, the real question is, would a prime number ever factor into any numbers that are not prime? Probably not. At any rate, that's the video. I'll make the code available. Check out the description. Take a look at the code. And in the next episode, we will take a look at optimizing isPrime to make it run faster. So please subscribe and, like the video if you want to see more. Thank you very much. Catch you later.